In this class, we're gonna see how to test for the first time your system once it's received. In the previous lesson, installation and unboxing, we saw how to connect the cable for the power. So right now we have this the laser power supply is connected, and we can turn it on. That the screen over here we have just 0. In order to actually activate this laser power supply, we need to use the key that are generally just stick them here on the top of the case. There they are. So you just insert the key over here and you switch on, and you will see now that the green dot over here will be lit, and we actually start to see the laser coming out from the objective. So if you don't see it, we can use just a piece of paper. Okay, there it is. So at this time we saw that the laser is on. I really recommend you to use, in particular if you are new to this method, to use protective glasses. Okay, so you can wear them just over your glasses, prescription glasses, and just to avoid any issue. Okay, so the idea is now we want to get our first Raman spectrum in order to be sure that the system is working as supposed to be. To do this, we will use this package you will find in your material. Is the calibration target. So inside you will find this adapter, and then this is the actual target we use for calibration. This one is just a piece of a common polystyrene standard, a piece of plastic basically. Polystyrene is used in many objects. Okay, so just here I cut a piece of it, and you can put here in this holder just to stand vertical, and we put this one in front of our laser. Okay, of the objective. Before we go to the actual measurement, let's discuss this knob over here. This one indicates the power of the laser. So for example, for you it's better to look like this. Okay, so you can see the green dot over here of the laser. When I turn this knob in one direction in this direction, you see the number over here increase. This number is just, let's say, it's the current that I'm providing to the laser. So the more the current, the more the power of the laser. So basically you see now this dot becomes stronger because I'm really increasing the power of the laser. And here we see some number 0.67 for example. Okay, so I can increase even more, so you will see this dot, the green dot, becoming even more visible. Okay, so well, the idea is what is the value I should use here. So I turn the knob until what number? The number you should put is written over here on the top. So here I put 0.52. This current, so this energy that we provide to the laser, means that from here, from the objective, we have an output of 1 milliwatt. So 1 milliwatt is the actual energy that is going into your object that you are analyzing. So this is what really matters for us, because basically 1 milliwatt is regarded as a safe value, a safe power a safe energy that we can use to analyze the object of art, manuscript, and so on. So definitely what you have to do is to go here and turn the knob until you read 0.52. So I'm turning the knob. To match 48, 49, 51, a little bit more, 52. 0.52, a little bit. Let's stabilize. Okay, 0.51, a little bit more. I mean, doesn't have to be super precise, just a tiny bit. 0.52. There it is, it's stabilized now. Okay, so now from here we should have a power of 1 milliwatt. For each system I measure the actual value from here because it will be a little bit different because how the laser is inside the reflection. So it's better for every system I tested. I test with a laser power meter, this one. So we can turn it on. Well, probably you don't see from there. Okay, so I go here with the laser power. So I read here 1.3 milliwatt. Okay, a little bit less, more, it's fine. I mean, we are in the range that is supposed to be. Okay. So basically we turn on the laser, we set up the right power supply, so 0.52 for this specific system. When you will receive your system, you're gonna read the right number for it. Okay, at this point we can go into the computer and preparing it for the acquisition with our system as we do as we did before for the first test. Okay, so here we are. So I made just an icon on the desktop for the ElviRa. So to make it more simple, to start with the elvira.exe file, and there it is. Okay, so this is the usual entry screen that we see when we launch the software. We see this, remember, this is a sinusoidal curve. This is important because it means that the system is connected, is recognized by the software. Then we go into Run and we check this box and we see the usual image of a system acquiring a spectrum. So it's all vibrating, so it's live. The things we need to do is to change the exposure. This tab over here right now is just 10 milliseconds. We want it to be at least 1000 milliseconds. So we add 00. So you see now the acquisition is much slower. One acquisition, the other, and so on. Okay, so the system is acquiring, the laser is set up. We can use our standard. So this is the polystyrene piece of plastic. We put over here over the objective and we get it closer to the objective. The working distance of this objective is 2 millimeters. So far, we can do just manually, because the idea is just to check if the system is working, so we don't need to be super precise, so just a little bit, we are free hand. So this is basically, okay, and you see, we start to see the spectrum. Pretty nice, and the idea is when we do this acquisition, we want to have the main peak of polystyrene. You see, the main peak is centered at 1000, so this is a big one, 1000 Raman shift. So this main peak at least should be 30,000 counts. So on the left, on the y-axis, we have these numbers, 30,000, 40,000. These numbers basically they are counts, so how many photons, Raman photons are detected. So for this peak, to check that the system is working, at least I want to have 30,000. So this will be our first test. So the system now is working properly. We see the spectrum of polystyrene. You can download from the class, from the online class, there is a polystyrene txt file, so you can compare if you see the same peaks. And this will be fine for testing that the system is working. So this test is good, you do it before any measurement, just to be sure that before measuring your manuscript or something, the system is working correctly. So you see the position of this main peak, 1000, the Raman shift, and then and the value of it. So with 1 second acquisition, you should have more than 30,000 counts. Okay, thank you. We go for the next class.